Okay, so in today's video we're going to go over partial fraction expansions, also called partial fraction decompositions. So first of all, what are they? Well, I think the easiest and most intuitive way to understand what a partial fraction expansion is would be to go over an example. So I'd just like to quickly run over how we get from these two fractions on the left to just one fraction on the right. Now the easiest way is probably just to cross multiply both sides by x plus 1 multiplied by x plus 3. So let's go ahead and do that. And for the right hand side, you'd see that the x plus 1 and the x plus 3 would all just cancel. And so we're left with 2x plus 3 plus 5x plus 1, which is 2x plus 6 plus 5x plus 5, which equals 7x plus 11. So now that we've gone from left to right, all a partial fraction expansion is just going from the right back to the left. So now that we know what they are, why do we want to learn how to do them? Well, the most obvious reason is that on a maths test or exam, you might just get asked a question like this: what is the partial fraction expansion of 7x plus 11 over x squared plus 4x plus 3? Which is just the example above, and we know that that would just be 2x plus 1 plus 5x plus 3. But not only that, they're also useful in further mathematics. For example, you might need them to do integration. They're useful for solving ODEs. And for engineering, you'll need them to do inverse Laplace transforms. Just before we get started doing some examples, I just want to go over a concept that kind of confused me when I was studying partial fraction expansions for the first time, which is that there are a certain number of forms that partial fraction expansions can take. Now, technically there are an infinite number of partial fraction expansion forms. However, online and in textbooks we are often taught that there is a certain number, like 3 or 4 or 5 forms. But for the purpose of this series, I'm just going to go over the most common 3, because I believe that with a fundamental understanding of these 3, it's quite intuitive to build the 4th and the 5th, or any other partial fraction equation form. So in the interest of logistical and navigational ease, I'll break up each of the partial fraction equation forms into its own separate video, then put all the videos into an ordered playlist, with the first video after this introductory video being the one on linear factors.